So the first class was laughing at me because I was like dancing up here while I was waiting for you guys to do it. Okay. Talk to me.
If tangent is negative, it's going to be a quadrant 2 or 4.
Agree?
And then if sine is less than 0, it's going to be in quadrant 2 or 4 as well.
No. 3 or 4. Yep.
Oh,
Okay. So tangent's negative tells me it's in 2 or 4. Sine being negative tells me it's in 3 or 4. So theta in this case is in 4 because that's where both of them happen. Okay? So theta here is in quadrant 4. Okay? Right? So my triangle, I'm going to draw my triangle to look like that, where this then is my reference angle. Tangent is what? Opposite over adjacent, right? So that would be 3 there and 5 there, which makes my hypotenuse be square root of 34. Okay? So then looking at I need cosine of theta. So I'm going to find the cosine of my reference angle. Ka, that would be 5 over the square root of 34. Sine of my reference angle. Tap the brakes. So would be 3 over the square root of 34. Right? Okay. Right? Now, that's of my reference angle. Of actual theta, cosine in quadrant number 4 is positive or negative? It's positive. So that's going to be, if I rationalize my denominator now, 5 square roots of 34 over 34. Okay? Sine in quadrant 4 is negative. So the sine of my actual theta is going to be negative 3 square roots of 34 over 34. Now I just need to find my actual theta. So the reference angle here is going to be the inverse tangent of 3/5, which gives me a reference angle of, if memory serves me right, it's something like, I don't remember, on inverse tangent, 3 divided by 5, gives me 30.964 degrees, or 0.540 radians. Right? But because I'm in quadrant 4, what do I have to do? 360 minus those, right? So that gives me a theta here of, I'm going to go 329.036 degrees, or theta here of 5.743 radians. Yes? Questions on that? Okay. Good warm-up. Love that warm-up. excited that I thought of that. Actually, excited that Mrs. Hill said, make a warm up. Got it? Okay. All right. What I need you to do now is I need you to find a partner and slide your desks together. Okay? Do it now. All right. What we are going to do today is we are going to be developing the curves for sine and for cosine. Okay? So, how we're going to do that is I'm going to ask you a very important question. Which one do you want to find first? Sine or cosine? Okay, let's find sine first. It's actually easier for me if we find sine first. Okay? I found that out in the last class. Okay? So, what you're going to do is you have a circle that looks like that. Okay? Right? That's the half sheet. Don't write on said half sheet because we're going through and using these all day today. Okay? If there's writing on it, it's okay. It's not. It's going to be just fine. Just don't put more writing on it. Okay? All right. Now, one thing that I need to tell you about these is that these are broken up into 15-degree increments. Okay? So these are in 15-degree increments, just so you know. Okay? Now, normally, when we are graphing a function for the first time, we make ourselves a t-chart. Okay? That's normally how we go about teaching you the function and seeing all the patterns and all of that fun stuff. Okay? So if I had a t-chart, my t-chart would normally look like that. Okay? And it would have x values here and y values there. And you'd pick x values to go into your function, and then you'd put those into your function, get out a y value, and then you'd graph the point x comma 1. Right? Okay? You've done it a bunch of times. I won't say that you've done it 1,000 times, but you've done it enough. Okay? Today, our XY chart, or our T-chart, if you will, is going to be with an angle as our input. So we're going to have a theta, if you will, in degrees or in radians or whatever you want it to be in, as your input. Your output on this particular one is going to be the sine of theta. Okay? All right? Because that's what we're putting, our function is x equals sine of, or y equals sine of theta. Okay? All right? So, how we're going to do that is you all have a piece of spaghetti with you, okay? And you have this one. Now, if I think about the unit circle, sine is what? Sine is y. So that's verticalness, right? That's up and downs, right? Okay? So if I go to my circle and I want to find the verticalness of 0 degrees, well, that's going to be wait, tap the brakes. Verticalness of 0 degrees, yeah, is 0. Because I'm right there. I'm not up at all. Right? So 0 degrees is 0 in terms of height. So I would put 0 right there. Okay? Now I go to something like, which one do you want to go? Looks like our graph is in 30-degree increments, right? Okay, so you want to go out to 30 degrees? Okay, so if I go out to 30 degrees, I'm going to take my piece of spaghetti. There is my piece of spaghetti. Okay, I'm going to take my piece of spaghetti and I'm going to go over here, and I'm going to measure. Oh, come on now. I got to bring it down a little bit. My spaghetti is too long. I want to go now. There it goes. That's some spicy meatballs. Okay. So I measured that vertical distance right there. And I'm going to break off my piece of, well, I should say I'm going to. You're going to break off your piece of spaghetti at that distance. It's actually not that bad. It's a lot easier than you think. Because what you do is you kind of make a little mark on your piece of spaghetti, and then you pick up the spaghetti, and you put your fingers on either side of that mark, and you pull it apart. It's really not that hard. Okay? All right? So that's my 30-degree line. So now I'm going to go back up to my graph. I'm going to take that piece of spaghetti, and I'm going to put it at 30 degrees, and at the tip of my broken off piece of spaghetti, that's where my function would go through. Okay? Then you go to 60 degrees. Then you go to 90 degrees, and so on and so forth. Go all the way around the circle. Now what happens when you go below, when you have to measure down?
Just measure down.
And so up here on your graph, you would be measuring down also. Okay. So you should have gotten a sine curve that looks like that. Okay? And then it would keep repeating. We call it a wave function, because it's just going to keep rolling over like the waves on the ocean. Okay? All right? So that's what your sine curve should look like. Everybody agree with that? Okay? And then your cosine curve should have looked like that. Yeah? Okay? So now we don't have time to get into the what do I want to call it? Not the obviousties of the cosine curve, but we'll get into that starting on Monday. So we'll get into things that the cosine curve has, things that the sine curve has, and so on and so forth. Our goal in this section is to take that sine curve and then translate it somehow. So we can shift it vertically, we can shift it horizontally, we can increase the period, we can kind of like accordion it, or stretch it out.